can equal the target. So then that would be not a ROM. Guys, what's going on? It's Program with Pags. Having a good old time with the soundboard. It's been a blast. It's been an in fashion of haven't had doing a an Algorithm Sunday episode in a bit. I figured it's about time. It's about time we brush it up. So and in honor of starting to dive into some of the the AI stuff, let's go ahead and crank out some algos, guys. So kind of haven't been dabbling too much in the Pythons. We have a 2-number sum here, so I think it could be a simple situation. So let's go ahead and get a little bit of tunes going here, and yeah, let's get started. So given one indexed array, let me turn it down actually a smidge. Given one indexed array of integers, numbers that is already sorted in non-decreasing order, find 2 numbers such that they add up to a specific target number. Okay, so I've done this before, I believe, in JavaScript many times. I think. Let me kind of code it in JavaScript, and then I'm going to transcribe it over to Python, just because JavaScript's obviously my bread and butter. So from what I understand, sorted in a non-decreasing order. So in a ascending order is what I'm understanding there. And we want to find 2 numbers such that they add up to a specific target. Let the numbers of index 1 and index 2 equal the target, right? Right? Is that what we're looking at? So my initial thought, let's ideate before getting in the code. My initial thought is going to be, I want to loop through the numbers array, right? Get my individual numbers. I want to set those numbers to the individual a variable, and then when I set a number, I can just do a J loop. So I have an I loop that goes through each number first, and then as I iterate with my I loop, so I goes to number 1, then J will just go down the line, and then we'll just sum them to see if it equals the target. Now that's the brute force approach. I think that would work great. I think that would work great, but I do think there could be a better approach, and that would be almost the hash map approach, where I saw that this is a little drawing tool. I'm going to try to do some drawing, guys. This will be fun. Nice. No way does that actually work. Now, how do I erase? Okay, so it does just erase. Well, let's see if it sticks on for a bit. So what I'm thinking is we have a sum, right? So we have a sum. Looks like a 5-year-old wrote that. but the sum, guys, how do I make it stay? You know what I mean? I need to make it stay, but let me not do it then. But basically what I'm saying is sum equals target 1 plus target 2, basically, or number 1 plus number 2, num1 plus num2. But another way of saying it is sum, just with basic algebra, right? Minus num2 equals num1, right? So if we do it this approach, I think the approach I'm going down is we can iterate through the loop 1 time. And if we know the target, we already know the target, right? We just have to subtract the target number. So this target is what we're given, actually. It's not sum, it's called target. So we just have to go through with one of the indexes, one of the pointers, and just keep track of the target behind us. Or the target minus that number, and then check the rest of the array for that number. And then if that array doesn't have that number, then we just move the index over. So we always keep the target here. Let's say the target's 7 and number 1 is 5. Or excuse me, let me try to write this in an array, right? So let's say we have 1, 2, 3, and 4. And if our target is, let's think about what would 1 and 2 equal? That would be 3, right? Let's say our target is 7. So our numbers array is 1, 2, 3, 4. So we can have our I loop just look at 1, right? So first we look at 1, and then we say is 7 minus 1, right? Do we have anything in our array that equals 6? And basically we can go through the rest of the array. So then we scan the rest of the array of 2, 3, and 4 and say, well, do any of those equal this number? No? Okay, then
oh God.
That's not the number we want, you know. So then we index this index over, right? So instead of it being 1, now this time we'll move it right. So instead of the index being pointed here, we'll move it to here, right? And then we say, well, 7 minus 2 is anything in the array equal to 5, right? And we look through the array, we put a J pointer here, we say no, and then we look through again and say no, and then we look through again and say no. And then ultimately we realize, okay, that doesn't work. So then we say, well, let's index this over. Let's move this guy over. We'll move the index over here. So then now this number turns to 3. And then we look in the array and say 7 minus 3. Is there anything in our array that equals 4? And we send a loop through to say, well, 2, no, that doesn't equal 4. Does 3 equal 4? No, but does 4 equal 4? 4 does equal 4. So then boom, we can return that. And at least validate that yes, this number array can equal the target. So then that would be not a ROM. The timing of that was amazing, folks. But I think that's going to be the approach. I think that's going to be the approach here. That'd be a good remix. But I think that's our approach. We could take that approach. So I'd say that might be the more efficient approach with a hash map. Versus the brute force approach, right? Let me kind of draw the logic out for that. Brute force would instead of this is the important step here of this approach is understanding the algebra that we can do. The brute force approach is really going to focus on this one right here. This just crushing through num1 plus num2 equals target. So we get the target right from the let's use the same example here. We get the target 7 from just the parameter, the outside variable, and then we could say, well, let's just run through the loop and say, well, 1, 2, and 3, and 4. Let me remove this I, guys. So here's our numbers, right? I don't know if I made that clear in the first one, but here's our numbers, and then here's our target. That's what's going to be passed into the function, and then we take our for loop and we say, well, let's start on I, and then we'll make the J loop like I plus 1 or whatever you want to call it, I plus 1. But we'll have one pointer looking at the first element, and the second element we'll have the next pointer looking at that. So we would then just look. The next step would be, well, is 1 plus 2 equal to the target? If so, return true. If not, it's not. And obviously that doesn't equal the target, so it would be false. And then we would obviously move the J loop over and say, well, does 1 plus 3 equal the target? False. No. Move the J loop over. You know, basically we just brute force the whole approach, right? No, that doesn't equal it over. So then we finally move the I loop over and say I and then J. Well, does 2 plus 3? You guys could already see we're doing vastly more calculations, right? No, it doesn't. Okay, well then let's do, oh, excuse me, I forgot to remove that one. And then we say, well, does 2 plus 4 equal 7? Almost, we're getting closer. Not quite. But then we finally move I over, and we get to the bread and butter of what we finally wanted, which was 3 plus 4 equals our target. So that is one way to do it. But obviously you could see that there's tremendously more code. And I think what we could also do, there's even another approach here too. So the brute force approach, I think would work pretty fantastic. But there's another approach even too that we can do, and it would be basically be indexing. We do have a small enough example here that it would be able to make it make sense. But I do need a bigger array just to show you guys. And maybe we can even add 6 to it. But there's a brute force 2, or maybe not even a brute force 2, I'll say force 2. It's not as brute force, but there's a little bit of stuff compared to the hash map way, where we're kind of just going through the array one time, which is I don't know, guys. It felt appropriate to do that. but the first way to do it is we put a pointer on. Let me copy this array down. But we put a pointer on each side of the array, on the left and the right side of the array. So we'd have a pointer here, I, and then a pointer at the tail end, J. And then we could have a target. This conveniently worked out. 1 plus 6 would be obviously 7. So let me actually put out a few more numbers in here just to build out the point, so it doesn't not show the logic so quick. But basically, we put a pointer at the beginning of the index, or excuse me, at the beginning of the array, and then we'd put a J pointer or a right pointer, if you will, a left pointer and a right pointer at the tail end of the array. So we'd have I at the beginning, and then we'd have J at the beginning, and based on the logic, right? We could say, well, 1 plus 9. Does it equal 7? Does it equal our target? And we obviously know it doesn't, so it's false. I keep seeing that because it keeps saving. So we know we're far above the target. We know that the answer is actually we have 10 instead of 7. So if we have 10, we know from a logic standpoint we don't need to move this. If we move I, we're only going to increase in value, right? So if we moved I over the left pointer, if you will, we would only go up in value. So there's a bit of logic on that too. So 2 plus 9 is 11, and if we kept that pattern up of just moving I over to the right, we're just going to keep increasing, right? So we know, because we've overshot our target, that we have to move the right index over 1. And these numbers are conveniently all the same value, but it is a sorted array, so that does help. So the easy part is we know now this approach of moving which pointer, because we know if we either overshot the target or undershot the target. So if we undershot the target, let's say for some reason, I'll pull out both things, but let's just keep running out this logic where we keep moving the overshot target over until we ultimately hit our goal, right? So let me show you guys how that works. Boom, and right here we would know, okay, boom, here's a solid, here's a truthful answer, and now our algorithm solved, if you will. But the other approach that well, the same approach but a different example, is let's say we didn't have all these other numbers, like we just had 1, 2, 3, 4, and we start on the far index. We would do the opposite. So this would be case 2 of the same approach, but we could do the opposite. So it would be 1 plus 4, and we know equals 7. That does not equal 7. False. We have 5. Because 1 plus 4 equals 5 does not equal 7, right? So we then now know we've undershot. 5 is below the target value, so we need to move this pointer to the right one, which increases this number, which we can get closer to 7. So false, we have 6. And because we're still undershooting the target, we can still move this one over one more, and then boom, we finally hit our target. So this approach can be faster than just the grunt brute force approach. You can see actually in both of these cases or similar cases, we had again, I wouldn't say brute force approach, just a little bit more efficient. I think this would end up being, I'm not even sure of efficiency. This will be definitely the most efficient in the least amount of space, but probably the hardest to code, I imagine. Brute force, I can crank this one out right now, but it'd be into time complexity, and I believe O of n space. So not the best space. This would be O of n space, but I think time complexity would be just O of n, or might even be n log n. I'm not entirely sure, but it's definitely going to be the fastest out of these three. And then this one, I think it's kind of in between the both of them. It's a fun approach. It's a fun idea, to play with the left and right pointers. But there's kind of three approaches here that we could take. So I would like to get this one down. Would be the easiest. I don't know how to do it to be transparent with you guys. So we're going to be solving it right now. But I do want to show the brute force, at least just immediately. So we can at least show an answer. But I will ultimately keep these notes up just so I can see them, and then I'll probably put them in the description for you guys as well. Actually, I won't do that. You guys can see them here. We ran through it together, so I have full faith that you guys are following along. So one under numbers length, and we'll say I++ to iterate through and get our number, which would be numbers at I. And then if I say for let j equals I plus 1, right? And then I could say j less than numbers length, I believe -1, and then we have j++. And this would be number 1 actually, and this would be number 2. So const number 2. Oh, I didn't close this here. Boom. And we would change that to a j iterator. And we could, I believe we could say if, I could even keep these together, right? So we say const sum equals number, or assigned, number 1 plus number 2. And we could say if sum equals target, right? I'm not sure what we're supposed to return. Is it return, let me move my face real quick. You may not use the same element twice. Your solution must use only constant extra space. So that is going to be the hash map approach. Totally going to be the hash map approach. Guys, did we do this already? Did we do this in Algorithm Sundays? Nah, if we did already, good practice. You know what I mean? Good practice. So knowing that it has to be, you may not use the same element twice, that does more than likely mean we're going to have to go with the hash map approach or the bottom approach, because the brute force approach does mean that we're gonna reiterate over 2, we're gonna reiterate over 3 potentially, or 4 even, depending on how big the array is. This one we would only be in one direction, and then I believe this one as well is constant space. Oh, and then we do return the output of these things. So in an array fashion. So it would be like this: number 1, had a hunch, number 1, and number 2. And I think that would be the algorithm if we could use extra space. I don't believe it'll work though, because we can't use extra space. So let's see. I'll go ahead and submit. You need to log in or sign up to submit. Well, ain't that a load of something? All right, we're going to pop over to CodePen. No time for all that. No time for all that, folks. No time for all that. And we're just going to pop it in here. Might as well, right? So function, I'm going to say function to number sum. Let me just do this real quick. And then at the bottom, I'll say console. Actually, we could do it at the top too. So we have all these notes here. Console log to number sum. And then I just need to pass it an array. So I'll pass an array and then a target. And I believe if I move my face again, the console will show, boom. And that's the answer, 3 and 4. That does equal our target of 7. And if we get rid of 4, let's see, it should return undefined. Well, 5 and 2 works, so. So I wonder if this is not working proper. I plus 1. Let's see. I know I've got the thinking down, but tactically, I know I'm off one here. So, let's see, undefined. So I think brute force, it's not going to give us the answer I anticipated. I'm not sure why. 2 and 5. Let me just see this real quick. Undefined. Boom. Okay, so I think that would be the brute force algorithm. Just needed to have a off one fix. So let's see. I'll delete the 5. See if we got our 3 and 4 back. We do. So that's brute force answer number 1, which does work. That's the code for it. In Python. Let's maybe pop this over, right? Let's see what it might be in Python. So if I go to Python, right, let's just transcribe this over. Good way would be to use ChatGPT, right? But let me move my face again, and let's see. So I'm not, guys. I need to get better with Python. 100% I do. So I do know. Yeah, guys, I'm gonna have to use ChatGPT just to see. It's been just too long. Can you transcribe this in Python? Let's start the journey. I've tried to get so competent with Python, like so fluent with it, but it's just always simple syntax that. So here's what we have: I range, length, and numbers. This is -1. So it looks like that's going to be copying this loop line right here. And then we do the same thing for j in range length of numbers. But we start at I plus 1, it looks like. We take number 1 equals numbers I, and number 2 equals numbers j, and sum equals number 1 plus number 2. If sum equals the target, return the array of these two. So boom. That is the same thing in Python as it is in JavaScript. And if I was logged in, it should in theory work. Again, this is the brute force approach, so it's going to be the slowest. And I don't even think it would actually meet the conditions of this. Your solution cannot have the same element twice. It needs to be constant space. So let's go ahead and try for the hash map approach, or the brute force 2 approach, or the force 2 approach, I should say. So, but hold on. We got to celebrate at least a little bit of a win, right? Right. A little bit of a win. Come on. Okay, so let's figure out this hash map situation, right? So const new set, I believe, is it? I'll say const hash map, right? Equals new set. And what I want to do is loop through the numbers. And I believe for let I, or I could even map through the numbers, right? Which effectively is a one-way loop. So number, right? And if the number isn't in the hash map, right? Let me think. Let's ideate again the logic. So we want the number that isn't already in the hash map, or do we want the number in the hash map? If the number doesn't exist so do we do number minus target and then check the hash map for the target, or do we do number, check that number's not in the hash map already, and then subtract it by the target? That's what I'm asking here. Need to think. All right, folks. We need a little jams or something, right? Little thinking jams. I'm not thinking at all, guys. I'm not thinking at all, I'll be honest. So I probably want to do let's say console log hash map, right? Let's see what's going on here. I'm gonna move my face one more time. So we have object set. Let's get rid of that. Say hash map, and boom. So we have that, right? And let's think. So how do we put numbers in the hash map? I kind of forget. So if hash map has, right, number, what do we want to do? Is this when we check? So I feel like I do need to get the number, numbers.length, right? Let's try this. Let's see how this goes. I'm gonna tuck this hash map stuff in here. Guys, I'm gonna get rid of the brute force. We're not gonna do that. But it would be another solution, right? Or a potential solution. I think so. So let's go ahead and say constant number equals numbers I. And we want to set number, right? So let me go ahead and console log number. See what we have. So we just get our array of numbers back, which is great. So I want to say if hash map does not have number, how about that, right? We want to say hash map set number. Oh. And then I want to see what the hash map looks like after. So let's go ahead and pop this in here. So if, we also need a key. So I'll say number. We need a key value. So number by number, I think that's how it works, right? Well, this is why we're doing it. So let's look up hash maps in JavaScript. I could obviously pop it into what's it called? ChatGPT, but that'd be kind of a little bit lackluster. We would take some of the enjoyment out. So it looks like we need to push it in. Data structures hash map. Let's see. So var hash. It just looks like an object that we need a key and then assigning the the key a value. So do we say number I? Is this what we do? Number? All right, folks. I'm giving in. I'm giving in. Can you help me? I'm solving this algorithm, but I'm not going to give in fully. I'm just gonna ask for a little help on the hash map. Can you give me a hint on the next step? Let's see what else we got here. Just setting the mood, setting the tone, folks. Okay, so here's what it says. It says it looks like you're on the right track. So that's what I said. Being fair, I'm solving an algo. Can you give me help on the next step? So let's see. So it looks like you are on the right track of using a hash map for a set. Storing values in the hash map. That's what I'm asking. How do we do it? How do we do it? So that's exactly what we want to do. The complement or the target minus the number is going to be the number that we look for. But this is what I want. Boom. Hashmap.set numbered. I swear to God we did that. I swear we did that. This is absolute wrong. And we just did the inverse. We said if the hash map does not have the number, set it. So so we'll try that, right? So this is the help. It's provided to return hash map and get the number. Let's see, get. Oh, it's hashmap.get. Oh, I see. I see what's going on. Okay, so I think it did solve it all for us, which is not exactly what we wanted, but I'm here for it. So let's see. Just wanted to console log the hash map through each step so I could see right what was going on. And then we'll say const target sum, which equals the target minus the number. I'll say potential, right? Potential sum. So in other words, this would be number 2. This would actually be number 1, if you will. Because in the other brute force approach, we just use the I iterator as number 1, and then the J iterator as number 2. But in this one, we're just going straight through, and we're given the target data, so we're using number 1 minus target. Does it equal the number to the right of it? No. Okay, then move on. Does it equal to the number to the right of it? No. Okay, then move on. So that is going to be roughly what we want, but we want to say if hashmap has number 2, then hashmap, I need to look on return hashmap get complement. Looks like an array. Oh, I see. So it's saying get number 2 and return the number. So this would be going through the hash map, I believe. We don't have number, we have number 1. Okay, so reference error number is not defined. Oh, right here, boom. And then return number 1 and the number 1. I swear we did that earlier. I'm gonna watch this back. Gonna watch this back. So hash map set is not a function. Oh, duh, guys. Hash map, new map. Well, that'd be why. That'd be why I'm not gonna watch this back then for that mess up. So on the first step, it looks like the hash map. Well, I wonder if it would show it here then. Maybe actually the thing I just want to see the hash map grow through each iterated step, right? To kind of understand it a little bit better. It doesn't look like it's really doing that. Let's see. Yeah, it's not really doing what I thought it would do. I thought it would show the actual key values here. So maybe I could say get number 1i, right? Maybe that would do it. Undefined, no. Okay, but it looks like that is going to be the answer though. And feel good about the logic part, not so much the execution on the coding part, but the logic's there, guys. The logic I feel good about. I feel good about that. So let's try it with more numbers. So if we say 12, let's see if it pops it up. 5 and 7, great. If we say 11, let's see if it gives us the solution. It should be 5 and 6. And it does. Perfect. Guys, I think it works great. 3 and 1, maybe. Nice. And then what do we do if it's too big? Does it say undefined? Nice. Guys, I think that's an appropriate time.
I love it. I'm sitting there.
I've got more material. Check it out the playlist. The Code Chronicles of me building a SaaS. Such an interesting series. Make sure to check that out. In the additional the additional videos below. Thank you, guys.